Okay, can you tell me the difference between pass by value and pass by reference in Java?
Yeah, so whenever we pass anything like primitive types and all in the method, so that is passed by value, and uh, whenever we are passing the objects and all, so that can be done through the reference.
Okay, can you explain bit more? Like suppose if we pass some value through the primitives, then what happens? And if we pass through the object, then what happens?
Yeah, let's say we have the any main method and we just say int let's say x equal to 10, and we are calling some method, let's say modify value. Okay, and inside that modify value we are passing this x. Okay, and this x is primitive type, and suppose inside that modify value, if we uh, update the value of this x to, let's say, some different number. Okay, and in the main method itself, suppose if we try to print the value of the x, it will be the original value itself. Like suppose earlier we had assigned 10, so it will print 10 only, so it won't change the value. I mean, whenever we change inside the method the modify value, so it won't change there. Instead, the originally whatever was assigned to that primitive type, that will be printed. Okay, and then suppose instead of in primitive type, if we pass, let's say, any object, let's say a person object is there, and p dot name, initially we put some let's say xyz, and next time inside the modify method, if we add p dot name equal to abc. Okay, so now in the main method, whenever we are trying to print that name, okay, that person dot name, so in that case it will be I mean, whatever the newly in the modify method, whatever we have modified, so that value will be printed. Okay, so um, that is how it works in Java.
Okay, what are the access modifiers you are aware of?
Yeah, we have public, private, protected, then default.
Okay, so default modifier, can it be accessible from the subclass?
Default, no, it will not be. Yeah, because whenever we have public, so that can be accessed from anywhere. Like it can be accessed within the class or package, subclass, or outside of the package or different package also. But whenever we have protected, then out in different packages we cannot access it. Otherwise, in the same class, package, or subclass, we can access. And whenever we have default, so that we can use only within the package, means within the package and within the class we can call that. But in the subclass and outside of that package we cannot. And in case of private, that can only be accessed from within the class.
So, yeah, okay, okay. Okay, let's say uh, we have a main class and we are trying to print 10 plus 20 plus some string hello. Okay, then again 20 plus 20. Okay, so what will be the output?
So in system out.println we are writing 10 plus 20, then plus string hello, then again plus 10 plus 20, correct?
Yes.
Yeah, it will be. 30, and then the it will be hello and 10 20, because uh, so initially the first two will act as integer because 10 and 20 are integer, so it will be integer addition, so it will be 30, and then we have a string. Okay, so any number when we try to concatenate with string, so basically it makes the whole thing itself as a string. So the 30 will be treated as a string here, so it will be 30 hello, and then after that since already we have this thing string as well, string only, so the after that anything is there, that all everything will be treated as string, so it will be 30 hello and then again 10 20.
Okay, okay. Okay, can you tell me your understanding about JDK, JRE, and JVM?
Yeah, so JDK basically is the combination of, we can say, uh, JRE, compiler, and some dev tools. And JRE basically is JVM along with the libraries, all that together we say JRE. So JDK is a Java development kit. So that is basically used for the develop and run Java programs. Okay, and JRE, Java runtime environment, so that is used to run the Java programs. Okay, and JVM is Java virtual machine, and that is used for to execute Java bytecode. So JVM basically converts bytecode into machine code. So and also it manages the memory, garbage collection, and all. And the JVM is platform dependent. Okay, whatever the OS we are using, let's say Windows, Linux, or whatever, so JVM will be that specific, but the bytecode which it generates, so that will be platform independent. Okay, and JRE, as I said, it will include JVM along with the Java libraries like Java Lang, Java Util, and all, so that will be the part of it. So basically, if you have to only run Java program, so in that case we can just install JRE. So we don't have to compile or do anything. So JRE will be enough in that case. And JDK is basically is for the developers. So whenever we write code and we want to compile it, right? So in that for that purpose we use JDK. So for debugging and all, so those development tools are used in this. So yeah, so this is the difference between these.
Okay, what is the difference between comparable and comparator?
Yeah, so basically both are used for the sorting purpose. So whenever we have the situation like we want to uh, use any default sorting, let's say only based on ID or only based on only one property we want to sort, so in that case we can go for comparable. But suppose there are the situations where when we have to sort it by multiple properties, okay, from of the object. Let's say we have a employee and that has name, salary, and multiple other properties. So we want to sort sometimes based on the name, sometimes based on salary. So in that case we can go for the comparator, but we have to only sort based on the ID. In that case we can go for the comparable. So that is the main use case. And apart from that, comparable is used in java.lang, so there it is present, and comparator is in util package. Then apart from that, comparable will have the method compare to, and it accepts only one parameter. And in comparator we will have compare method. Okay, and then the sorting logic is defined in class itself in case of comparable, but in case of comparator that is defined separately. So yeah, so these are the differences there between comparable and comparator.
Can you tell me the difference between double equal to and dot equals?
Yeah, sure. So double equal to basically is used for the reference comparison, and dot equals is for the actual content of that variable. If it is double equal to, then it checks if two variables point to the same memory location. Okay, so basically if they are the same object, then only the reference comparison tells it is true. But whenever we have dot equals, then if like it is the method that checks whether the content of the two objects are equal. Okay, so for example, let's say we have in case of a string, we have a string s1 equal to, let's say we are using new keyword, new string of hello. Okay, the string is hello inside that. And again, if we are also using s2, s2 equal to new string of hello. Now whenever we say s1 double equal to s2, so in this case it will return false. Okay, because the objects are different. Okay, the reference uh, are different. But whenever we say s1 equals s2, in that case, since the content is same, which is hello, so it will return true. So yeah, so that is the main difference between these two.
Okay, fine. Now suppose we have one integer, the wrapper class, right? And we say integer x equal to 127. Okay. And again we say integer y equal to 127. Okay. Now when we say x double equal to y, then what will be the output? And when we say x dot equals y, then what will be the output?
Yeah, actually, in this case, it will be true in both of the cases.
Okay. And why so?
Yeah, because in case of integers, Java caches from like minus 128 to 127. So so whenever we are putting this number 127, which is within the range, so it will basically uh, internally it will be doing integer dot value of actually. So in this case, because of the same cached object, so it will be true. And whenever it is double equal to, and equals, obviously it is because the values are same, then it is true. But suppose if the number is outside of this range, like it is suppose x equal to 128, so in that case it will behave as like a new integer object has been created every time. Okay, so in that case, uh, if we say x double equal to y, so that will be false. But yeah, the content means the x dot equals y, whenever it is 128 it will be true, but x double equal to y, that will be false. So yeah, so this will be a difference.
Okay, and what is the difference between interface and abstract class?
Yeah, interface can have only abstract methods. I mean before Java 8, but after Java 8 we can have a static and default also. And then abstract class can have instance variables, but in interface we can have public, static and final, like constant variables. Okay, and then uh, abstract cannot support multiple inheritance, but in interface that supports multiple inheritance. So yeah, and also in abstract class we can have the protected and public members, but in interface all methods are like public by default. So yeah, so these are the differences between these two.
Okay, do you know exceptions? Can you tell me the complete hierarchy and everything about exceptions?
Yeah, so basically on the top we have a throwable class, and then this has again exception and error. So exceptions are those which can be handled, and error are those which we cannot handle. and this is kind of irrecoverable situation. So error are like whenever we have virtual machine error or out of memory error, stack overflow error, so all these comes under the error. So these are because of the some different scenarios, like system has issue, it does not have the memory, so those kind of things which is not under the control of the developer. But an exception that can be handled. Uh, exception again is divided into two parts. One is checked and one is unchecked. Okay. So the checked one is basically happens at the compile time exception. Okay. And unchecked ones are the runtime exception. Okay. So checked one. So at the compile time, suppose whenever we are dealing with some files or something, so uh, maybe there are the chances that file is not there, so we should, so basically compiler tells us that we should must handle it like file not found exception. We should have it there, because if we don't declare it there, I mean that exception, so I mean we will not be able to compile only. Okay. So the exceptions like IO exception, SQL exception, and then this is file not found exception, so all these comes under the checked exception, which is compile time. And then at runtime, that happens at runtime, so those exceptions are like arithmetic exception, array out of bound exception, then null pointer exception. Okay. Then concurrent modification exception, so all these happens at the runtime. So this is what is the main difference between I mean these two, and this is what is all the hierarchy we have in exception.
So what is this concurrent modification exception when we get this at runtime?
Yeah, concurrent modification is a runtime exception that occurs on the collection like array list, hash map, and all. So suppose we have this array list or hash map and we are trying to modify it while it is being iterated. Okay, using the iterators that do not support the concurrent modification. So in that case, this concurrent modification happens. So let's say for example we have the list, okay, and array list, and we just add some items to that, and we are trying to iterate using the, let's say, for each loop. Okay. So uh, in for each loop, let's say, like we are just trying to remove them some specific item, some specific element out of that array list, so using list dot remove, so at that time it will throw the concurrent modification exception, so that is not allowed. So yeah, so that is the concurrent modification exception.
Okay, and how we can get rid of that?
Yeah, to get rid of that, we can use either iterator dot remove. Okay. So whenever we are iterating an array list, so we have iterator dot hash next, and then uh, like the iterator dot remove, if we will say, so we can safely remove it. And there is another way, like we can create the copy of that array list, so we also have a copy on write array list. Okay. So that is thread safe, and if multiple threads are modifying a list, so we can use this copy on write array list. Okay. So in this case, whenever we say we use this copy on write array list, so in this case using the simple for each loop also, we can remove the item from the list, so that won't throw, because it creates the copy internally from the actual array list. Yeah. And similarly in case of hash map also, we can follow the same. So in hash map also we can simply use iterator, and whenever we say iterator dot remove, it won't throw the concurrent modification exception. So yeah.
Okay, okay. Okay, what is volatile and synchronized in Java?
So volatile basically ensures that a variable's value is always read from the main memory, not from the CPU cache memory. Okay. So basically this is very much useful in the multi-threading situation. Now synchronize basically ensures that only one thread can access a method or a block at a time to avoid any kind of uh, in the multi-threading scenarios. So basically synchronize is used for the thread safety.
Okay. So what is immutable class?
Yeah, an immutable class is a class whose objects cannot be modified after they are created, and any modification results in a new object being created instead of changing the existing one. So that is what is the immutable class. So for example, we have a string, so that is immutable. So yeah.
Okay. So why string has been made as immutable?
Yeah, string has been made as immutable because of various reasons. So first reason is because of the security purpose. So suppose any kind of network connection or something we are doing, so basically it prevents unauthorized modifications. So whenever we are connecting with databases or in URLs also, right? Whenever we have any link, right? So in URLs also we have, then password is there. So those things cannot be modified. Okay, so that is the one reason. Then string literals are stored in a string pool. So for the caching purpose also this is immutable. And also a string is basically thread safe. Okay, so it is for the synchronization purpose also, that is thread safe. And also it is immutable, so because of that the it also impacts on the performance. So it basically reduces the memory overhead in the application. So yeah, so these are the reasons why string is immutable.
Okay, so how do you create your own immutable class? Custom immutable class?
We can do it using so first step is like all the fields we have to make it like private and final. That is one thing. Then there should be getters, but there should not be any kind of setters method. Okay, and then the class itself is final, because to prevent it is being subclassed. Okay, so that class itself should be final. And then any mutable fields should be we should handle it carefully. For example, we have arrays, collections and all. Okay, then if we have any mutable fields instead of direct references, so we should return the deep copies of the mutable fields. Okay, if any objects are there, so instead of shallow copy. and uh, and yeah, so these are the steps we have for the custom immutable class.
Okay, so can the main method be overloaded in Java?
Main method, yes. Yeah, I think yes, that can be overloaded, but it won't be called by JVM as part of the program's execution. So JVM usually calls only the the main method with one argument, right? String, array, args, right? So that is the only method which can be called by the JVM. But if we want to overload main method, means we can write the method, but uh, we can further, like from the main we can further, let's say we have a public static void main and we are passing argument as int x. Okay, so from the main method further we can call main of 5 or any number, so that will call that main method with that integer as argument. Okay, so that way we can call, but yeah, JVM will not call.
Okay, so have you seen this being done anywhere?
uh I have not seen, but uh, I mean that might be called when, I mean, this scenario might be done whenever we want to do for some testing purpose. Let's say we might want to test some certain logic using different parameter types. Okay, so in that case, there are the chances that someone can do like this. Also, sometimes if you want to keep the custom starting point for different configurations or scenarios, like having different entry points for testing purpose, so in that case also the chances are there we can overload main method. So yeah.
Okay. Okay, what is class level variable and instance variable?
Yeah, so class level variables are nothing but the static variables. Okay, so they are the member of the class, they are the part of the class. So instance variables are associated with the instances of the class. So whenever we create the instance or object from the class, so each object of the class will have its own copy of the instance variables. Yeah, so instance variables are associated with instances or objects of the class, and each object of the class will have its own copy of the instance variables. Okay, so instance variables are basically declared inside the class but outside of any method, okay, or any constructor or any block. So it belongs to individual objects, and each object has its own copy of the instance variable, and also they are initialized when an object is created. So whenever we say new of that class, then only it is initialized. Okay, so these can only be accessed by the non-static methods. Okay, now coming to the class level variables, so they are nothing but the static variables. Okay, so we use the static keyword for this. So these are shared by all instances of the classes. So unlike instance variables, there is only one copy of the static variable for the entire class, okay, regardless of how many objects are created. Okay, so there will be only one uh, copy of that. Okay, so these static variables can be accessed without creating an object of the class using the class name. So we can just say that that class name dot that variable name, whatever we have the static variable that we can give, and then we can good to access that. Okay, so yeah, so these are the initialized only ones. So yeah, so this is the difference between these two.
Okay, so in Java 8, what is lambda expression?
Yeah, lambda expression allows us to write concise and expressive code by passing behavior, nothing but the functions as argument to method, or using them to implement interfaces with a single abstract method. So suppose any interface is there and that has only one method, so we don't have to write the whole method name and the complete code. Instead we can just simply in the brackets we can pass the parameters, and whatever the operations are being performed inside that method, we can simply write that operation. So basically this way it removes lots of boilerplate codes. So yeah, that is what is a lambda expression is.
Okay, what is functional interfaces?
Yeah, a functional interface is an interface with just one abstract method, okay, and which can be implemented using a lambda expression. So it can have only one abstract method, but it can have any number of default and static methods. Okay. So already we have inbuilt like runnable, comparator, then consumer, supplier. So all these are the functional interfaces provided by the Java. So yeah,
Okay, what is optional in Java 8?
yeah. Optional is a container object introduced in Java 8 to handle null values, and it is basically used to avoid null pointer exception. It also improves code readability, and this is the part of we can say like functional programming. So earlier before Java 8, whenever we had to check the null, we had to do the null check. Then we will have to do the um, manually we used to write the code, right, if the object is null and all. But after Java 8 onwards, uh, we don't have to write that manually. Instead we can use optional class. So for example, we can use optional dot off null label, and whatever inside that, if that returns null, so that can be gathered to the optional of, like, if it is a string, then a string, and then with the object of that. So basically we can check the length of the whatever the return has been given by the optional of null label, and if the length is uh, I mean uh, not 1 or less than 1, then we can simply say like 0 we can return. So we can smartly handle the null pointer exception here.
Okay. Can you tell me the few methods of it?
Yeah, for example, off I told, and then off null label, is present, then if present, and then or else we have the map. So these are the methods we have in optional.
Okay, okay. Okay, now can we call a static variable inside an instance method in Java?
Static variable inside instance method. Yeah, we can access static variable inside the instance method. Since a static variable belongs to the class and not to a specific instance, so they can be accessed from both static and instance methods.
Okay, okay. Okay, so we have runnable interface and we have a thread class as well, right? So which is better for implementing?
Yeah, both runnable interface and thread class can be used to create and execute threads in Java, but runnable is generally considered better practice than extending the thread class. So whenever suppose we are using a thread, so suppose any my thread extends thread class, so that is fine, that can be done, but it cannot extend any other class. Okay, so it is not flexible for any other further implementation. But whenever we have the runnable interface, so suppose any class we are using my runnable and implements runnable, so uh, it allows multiple inheritance. So since Java does not support multiple class inheritance, so it allows multiple inheritance and separation of task and thread execution, so that makes the code more reusable. So yeah, so this way is much more better way.
Okay, let's say we have a class called, let's say, my class, and that extends thread and also implements runnable. Okay, so can we do like that? Is it allowed? So we are extending thread as well as implementing runnable at the same time.
Yeah, we can do that. It won't show any compilation error, but it's not a common practice which I have seen, and I think usually we should avoid this because it basically defeats the purpose of separation of concerns. So that is one thing, and the thread class itself already implements runnable, so extending it automatically provides run. So I mean, doing both things again together, it doesn't make any sense to do that.
Okay, okay. Okay, so what is JPA? You know JPA?
Yeah, JPA is Java Persistent API. So that is a Java specification for managing relational data in Java application. So along with that, we use the like we can use Hibernate and all for the its implementation. So it provides, so JPA basically provides an abstraction over the database interactions. So it makes it easier to work with the relational databases without writing complex SQL queries or managing database connections manually. So basically, before JPA, developers had to use JDBC or frameworks like maybe Hibernate directly to interact with the databases. But using plain JDBC had many other issues. So developers mostly had to write the SQL queries manually and handle exceptions and all. And we used to convert the result set into Java objects manually. But when JPA came into picture, so we have it has removed various boilerplate JDBC codes, and there is no need to manually map the Java objects, okay, from the uh, whatever the data which has come from the database. So we just write a bean class, and we mention the objects over there, the properties we can mention, and that can be automatically mapped with the uh, whatever the data which we are bringing from the database. And JPA also automatically manages transactions, so that reduces the chances of errors, and it also provides caching mechanism. So yeah, so all these uh, I mean benefits are there.
Okay, can you tell me the commonly used tags of JPA? Let's say inside the entity class, what are the various commonly used tags?
Yeah, there are various tags like at the rate of entity is there, then at the rate of ID is there, table at the rate of table is there. Okay, then for the primary key, at the rate of generated value, I mean we want to automatically generate the IDs. So strategy we can mention there, and then the load type eager or lazy. So that is there. Then one to one, one to many, many to many, many to one. So all these notations are there. So yeah.
Okay. Okay, what is the difference between load and get in Hibernate?
Yeah, the load method is used to fetch an entity lazily from the database. So it returns a proxy object, which means that the actual database query is not executed until you access a field of the entity. So basically, it returns the proxy object, and it is good in case of we need only a reference, not actual data. And since it is returning the proxy object, it is faster in performance. Okay, then coming to get method, that is used to immediately fetch an entity from the database. So it directly hits the database and returns the actual object. So it is basically slower because it returns the actual object.
Okay, so in Spring, what is dependency injection and what is IOC?
Yeah, both dependency injection and IOC are core concepts of Spring Framework, and they help in managing the objects dependencies efficiently. So IOC is a design principle, we can say, where the control of creating and managing the objects is transferred from the programmer to a framework or container. And uh, dependency injection is a specific implementation of IOC where the required dependencies are injected into class instead of being created within the class. So there are various types of dependency injections are there, like constructor injection is there, setter injection is there. So yeah.
Okay, how constructor and setter injection is implemented? Can you share some code snippet?
Yeah, so if we have constructor injection, then suppose we have a class, and so uh, the we will create a constructor, whatever the suppose the class name is client, and we will create a one more constructor with public client, and there on top of that we can say at the rate of auto add, and uh, inside this constructor we can set suppose the object is service, so this dot service equal to service we can say. And in case of setter injection, so we will have the setter method will be there, public void set service, and then we will have the service parameter there, and on top of this setter method we can write at the rate of auto add, and again inside this method we can say this dot service equal to service. So like that we can do.
Okay, okay. So, what is the difference between Spring and Spring Boot and how they are different?
Yeah, Spring Boot is an extension of Spring framework only. So the base is Spring only. Okay, so that simplifies the development of standalone and production ready and microservice based application. So the major difference is like in Spring we can also use XML based configuration, but in Spring Boot uh, like we don't have to configure it manually, mostly it happens automatically, so it auto configures everything. And Spring we will have various boilerplate codes, but uh, the some boilerplate codes has been removed by, for example, uh, with at the rate of Spring Boot application we have, so that internally does many things. So using that it removes lots of boilerplate code, and then the Spring will not have any embedded server, so we need to have external Tomcat or JT, whatever server we want. But Spring Boot comes with embedded Tomcat, so we don't have to worry about that. And even if we want to change that, we can change that Tomcat to some different server as well. Also, in Spring, for suppose if we have to set up the actuator and monitoring thing, then we need to do the additional setup for that. But Spring Boot provides built-in actuator, so we have to just add the dependency and we are good to go. So yeah, these are the differences there.
Okay, so in Spring Boot, how do we disable auto configuration for any specific class?
Yeah, if you want to disable auto configuration for any specific class, then um, in the main we can just say at that of Spring Boot application and then exclude equal to that class name which we want to exclude, so that we can give, so that way we can do it.
Okay, okay. So in microservices, first of all, what are microservices and how they are different from monolithic architecture?
Yeah, microservices is an architectural style where an application is divided into small loosely coupled independent services that communicate with each other. Okay, so in monolithic so whenever we have to do deployment, so one large code base will deploy together, but in microservices we need to deploy multiple small services called microservices. Okay, so that is the first difference. And then monolithic, it is very much difficult to scale any specific part. Suppose uh, in some specific section, let's say in the electronics section lots of demands are coming and more traffic is coming, so we cannot scale that specific part. Instead we will have to have the bandwidth for the whole application itself. But in case of microservices, each service scales independently, so that is better in this kind of situation. Then uh, in monolithic architecture we will have only one technology. So if suppose we are using Java, so entire application will be in Java itself. We cannot use any different programming language. But in case of microservices architecture, we can use like different technologies. So since we have multiple microservices, so each microservices can have its own database and its own technology. So we have to just make sure that they communicate with each other. Okay. So yeah, so these are the basically major advantages.
Okay. Okay. What is service discovery in microservices?
Yeah, service discovery is a core concept in microservices that helps in locating services in a distributed system. So in microservices, services are typically dynamic and can be added, removed, or relocated at any time. So microservices are basically dynamic. So in a microservice based architecture, services are constantly scaled, upgraded, or replaced. So keeping track of their locations manually. Then service discovery also helps in balancing the load by keeping track of multiple instances of the same service and routing request to an available instance. So service discovery basically operates in two primary modes. So one is the client side service discovery. So in this approach, the client is responsible for determining the location of the service. The client queries the service registry for available instances of the services and then selects an instance to send the request. Okay, and then we have the server side service discovery. So in server side service discovery, the client makes the request to a proxy or for example API gateway, and proxy is responsible for discovering the service instances and routing the request to it. So the API gateway or load balancer queries the service registry to find the appropriate service instance. So yeah, so that is how service discovery works.